electric lights in the main roadway. The layout of a typical mine will look like this. There are two shafts. The one on the left carries men and materials, and the other carries coal. The train takes men from the bottom of the shaft and drops them off at a point nearest to their place of work. Men working at the coal face will have to walk the last few hundred meters along the side tunnel leading to the face. This is what is called a long wall face. These days, almost all of the deep-mined coal in Britain is won by this method. The coal face is, in fact, a long wall of coal. The cutting machine takes slice after slice from the face, and it usually advances into the coal seam. This surface demonstration shows how the machinery works on the coal face down below. Hydraulic-powered supports are set along the length of the face, about 1.5 meters apart. They act against the pressure of the rock strata above the coal face. As it moves along the face, the shearer loader, as it's called, cuts the coal and pushes it onto an all-steel conveyor, called an armoured face conveyor. The roadways at either end of the face are excavated to keep up with the coal face as it moves forward. Ventilation of the face is provided by diverting fresh air along one roadway known as the main gate. In the main gate, another conveyor belt carries the coal away from the face. The other roadway, which carries stale air away from the face and serves as a second entrance for supplies, spare parts, extra girders and so on, is known as the tailgate or return gate. It can also be used as a second exit in an emergency. Here we are in the main gate, and these men are going onto the coal face to start their shift. The cutting drum of the shearer loader has dozens of hard steel picks fitted to it. The shearer loader is driven by an electric motor of up to 400 horsepower, rotating the cutting drum and driving it along the face. Water sprays around the drum cool the picks and help to keep down dust to a strictly controlled level. A second cutting drum is fitted to the other end of the machine so that it can work in either direction. Most long-wall coal faces are between 150 and 300 meters from end to end, so there may be up to 200 powered supports along the face. Behind the shearer, the hydraulic-powered supports are moved forward, pushing the conveyor into the space where coal used to be. The face will then be ready for the shearer to take its next slice of coal on the return journey. It's hard and skillful work, keeping this machinery on the move 6 or 7 hours at a stretch, so the miners are glad of a break in the middle of a shift. Snap time, they call it. While the men on this face are taking a break, the coal from other faces in other districts keeps on flowing out of the mine, transferring from one conveyor to another to emerge from the mine some 250 million years after it last saw the light of day. In addition to coal obtained by deep mining, some 15 million tons of coal a year, about 1/6 of our total production, is won by open cast or strip mining. Coal seams less than about 100 meters below the surface can be worked by removing the soil and rock, called the overburden, with machines like this one, nicknamed Big Geordie. Weighing nearly as much as a cross-channel ferry, its huge bucket can lift 100 tons of material with a single bite. As one part of the site is excavated, the overburden is transferred in a fleet of big trucks to refill those areas from which the coal has been extracted. When the operation is complete, the topsoil will be replaced, trees planted, grass grown, and the land restored to use. Most of the coal we produce, whether from deep mines or open cast workings, will go to a coal preparation plant. As it passes through the plant, a series of processes grade and wash and test the coal to ensure that customers get the size and quality they require. More than 2/3 of the coal mined in Britain goes to feed the power stations to make electricity. This is Drax Power Station in Yorkshire. It's capable of burning 10 million tons of coal a year, making it the largest coal-fired power station in Europe. This train, carrying 1,000 tons of coal, is called a merry-go-round train. They're called merry-go-round trains because they travel on a circular route from mine to power station and back, and are able to load and unload without stopping. This whole train of 30 wagons is loaded in as many minutes. For the foreseeable future, electricity generation will remain the largest single market for coal. Electricity from these large and efficient power stations is distributed throughout the national grid system to give us light, power the gadgets in our homes, run a large part of our railway system, and supply power to thousands of factories. But coal is now recapturing its traditional markets. Large industrial and commercial customers are converting from other fuels and returning to the use of coal for steam raising, to heat workshops and offices, and to provide energy for industrial processes. Coal traditionally supplied the country's manufacturing industries with energy. Millions of tons of coal a year are still turned into coke. Most of it is used to make iron in blast furnaces. These rotating kilns produce cement. The process uses the heat from coal. As an increasing proportion of our total coal production comes from new or re-equipped collieries working at high efficiency, the mining industry will steadily regain its preeminence in these industrial markets. Deliveries of coal can be made in different ways. It can be placed in bunkers or storage hoppers, precisely, easily and cleanly using specially designed road vehicles. Industrial water heating and steam raising units like this make use of the latest electronic control techniques to make the best possible use of the coal they burn. The coal is fed in automatically and the ash is removed automatically. The rate at which the coal goes into the furnace and the flow of air to make it burn, even the water and steam valves, can all be remotely controlled from outside the boiler house. In the coal fields, a number of companies use the explosive gas methane as a fuel. The gas seeps out of the coal seams and is known to miners as fire damp. For each ton of coal mined, about 6 cubic meters of methane gas is released, enough to run the gas central heating system of a 2 or 3 bedroom house for a couple of weeks. The methane is drained away from the seam before the coal is cut, another important safety measure in modern mining. New ways of burning and using coal are being developed at the board's coal research establishment. Fluidized bed combustion is one of the most important. It is making possible an increase in the market for coal as a fuel for industry. When air is blown into the bottom of a container full of a finely divided or ground up material such as sand, the mixture behaves just like a liquid. If the sand is red hot and the coal is fed into the fluidized bed, it will burn in the supply of air passing up through the bed. Chemicals can be added to the bed in order to absorb potentially harmful gases before they leave the furnace, to the benefit of the environment. Eventually, the system of combustion will be used on a much larger scale in electricity generation. Already, many fluidized bed boilers are in commercial use and many more are planned. For several years now, in this boiler house, a fluidized bed boiler has been working alongside more conventional steam raising equipment, which supplies a district heating scheme comprising hundreds of flats, houses, offices and shops. The local Olympic-sized swimming pool also gets the benefit of low-cost heating. Coal supplied the country with gas long before natural gas supplies were discovered beneath the North Sea, and no doubt will have to do so again as offshore gas and oil reserves dwindle. As well as being a fuel, coal, just like oil, can be processed to supply many different chemicals. Drugs, dyes, paints, plastics, fertilizers and explosives, all have been made from coal. There are some applications for which raw coal itself could never be used. But even oil can be made from coal. The process has been successfully operated in the laboratory, and a larger scale pilot plant will develop the process further, so that by the late 1990s, commercial scale plants will be able to turn coal into fuel for aircraft, diesel and petrol vehicles. The future success of these ventures will depend upon the mining industry's ability to meet the requirements of the energy market at competitive prices. Exploitation of newly discovered coal reserves make this possible. Sometimes this will be done by modernization and extension of existing collieries. The revolutionary design of these new headstocks is an example of the coal mining industry's concern for good industrial design. The Selby project in Yorkshire is a completely new coal field, about 100 square miles of thick, good quality coal seams. Designed by a team of engineers and architects from the ground up and down. All the surface buildings and equipment were carefully sited and designed to minimize the impact on the rural surroundings of this huge industrial undertaking. 5 pairs of mine shafts will be used to carry miners and equipment. They also provide air for ventilation of the underground workings. All of the coal is carried on underground conveyor belts. The main ones, more than 9 miles long, stretch right across the coal field. Coal can be brought to the surface at a rate of 2,000 tons an hour up this drift or sloping tunnel to a depot beside the main railway line. The loading machinery here can fill up to 50 trains, each made up of 30 wagons every day. Mines like Selby are enabling deep-mined coal to be produced efficiently and cheaply, to supply customers at home and to allow Britain to maintain its exports of coal. Much of our coal which goes abroad these days is sent through the board's specialised bulk handling terminal at Immingham on the Humber estuary. A remotely controlled conveyor belt system allows a few men to pick up the coal from the stocking ground and drop it accurately into the hold of a large bulk-carrying cargo ship. The search for coal goes on. Over a period of 10 years, even more reserves of coal were discovered by seismic survey than the entire amount mined during the same period. The new discoveries are explored from the surface by drilling rigs like this. Despite our long history of coal mining, the existence of an additional 1,500 million tons of high-quality, accessible coal was confirmed. Drilling was carried out at sea as well as on land. In the northeast, coal is already being won from faces 10 kilometers offshore and 300 meters beneath the bottom of the sea. These rigs enable geologists to take samples 1,000 meters or more below the surface. The coal prospectors make an initial inspection of the core, as it's called, and then send it off to laboratories for detailed analysis. It takes up to 10 years and many millions of pounds to sink the shafts and develop a coal field. And the engineers don't want any surprises when they eventually get down there. A comprehensive exploration program is still building up a detailed map of our island of coal. These geologists are taking a look at the future of coal mining in Britain. The task of Britain's high-technology mining industry is to meet the undoubted future demand for coal at the minimum possible cost. British mining has a long history. It can look forward to a shining future.